Okay there, so in order to move forward through the rest of Chapter 6, we just need to firm up the concept of the antiderivative and make sure we really understand that really well. So previously, in previous chapters, we've defined the derivative with the f prime notation. That's Newton's notation of how he would write that. So we know that to be the derivative. And you're comfortable with f of x being function notation. And so what we want to introduce is the notation for an antiderivative, which is done with a capital letter. So capital F of x is going to indicate the antiderivative function. So it's sort of a hierarchy or a series of functions which move from one to the other. And we've played around with this idea a little bit before. We've talked about functions that are like this. So if we had the derivative was given to be 4, then you were you knew that the function would have been 4x. All right, so in other words, if the slope was 4, then the derivative would be 4x. We also talked about the idea that there could be a plus 0 here that you wouldn't necessarily see, and so then the original function could have had a constant on the end, plus c, which when you took the derivative to check your work would disappear into 0. So as we work with the concept of an antiderivative, it's always important to remember that that plus c could be there. So another one that we have looked at before. So if we've got g of x, and that's defined as 2x, and we want to know what capital G of x would be, which would be the antiderivative. You've done that enough times to know that 2x comes from x squared, but again, there could be a plus c constant on there, which when you take the derivative to check your work, would disappear. So every time you do an antiderivative function, you need to remember to add the plus c. So you've got some common rules for the derivative. So let's compare f prime of x. Well, now that we've talked about notation, let's talk about some of the rules. So let's think about that x squared. If you have x to any power, x to the n, we know that the derivative, we've already learned that, is you pull the power to the front, and then x's power decreases by the number 1. So we multiply by the power, and we decrease the power. So how does that work for an antiderivative? Well, you got to do everything backwards. Instead of decreasing the power, you're going to increase the power. Instead of multiplying by the old power, you're going to divide by the new power. All right, so you increase the power, and then you divide by what that new power is, and you add the constant c. So that allows us to do some more complex antiderivatives. So for example, if we have h of x, and that is going to be x to the 4th, well then capital H of x, all right, we're going to increase the power, so x to the 5th, and we're going to divide by that value of the new power. And we're going to add the constant. Likewise, if we were given r of x to be x to the 1/2, then its antiderivative follows the same rule. So x is going to go up a power. We're going to add 1, and when we add 1 to 1/2, we get 3. Oops, that's not very good. 3 over 2. And then the rule is you divide by that new power, which would also be 3 over 2, and then you add the constant c to represent the value of any constant. And it's pretty typical not to leave it that way. Instead of dividing by an awkward fraction like that, we would multiply by the reciprocal, so it would be 2/3 x to the 3/2 plus c. You also might see that more commonly written as 2/3 times the square root of x cubed plus c. That would be a more typical way to write that as an answer. This also would work for the function defined as t of x being equal to, let's say, x to the negative 2/7 plus the sine of x. All right, if we want to do the antiderivative of that, so that would be capital T of x. So x to the negative 2/7. When we add 1 to that, that's adding 7/7. So I'm going to get a positive 5/7. I have to divide by the new power, which is also 5/7. The antiderivative of sine, right, well, remember how the pattern of sine and cosine goes, that sine has a positive derivative of cosine, and then cosine has a negative derivative of sine, which has a negative derivative of cosine, and then we're back to regular sine again. So those are the derivatives. But if you do the antiderivative, you're going backwards on that. And so the antiderivative from sine would take you to negative cosine. And so our antiderivative will be minus cosine of x, and then plus c. If we want to clean that up a little bit, it would be more typical to write that as 7/5 of the 7th root of x to the 5th minus the cosine of x plus c. All right, the last thing that we want to talk about is what we could do additionally with that plus c. And you can figure out exactly what the value of that plus c is supposed to be if you have what's called an initial condition. That means a value for x and a value for y. That would help you narrow that down. If you don't have that, c represents any constant. But if you do, then we can narrow that down. So if we have g prime of x given to us as the quantity 3x to the second, and if we're given an initial condition that the function goes through, and you need a value for x and you need a value for y. So we're going to say it goes through the point -1, +1. So we're going to go ahead and find the antiderivative. So that'll be g of x is, and then we are going to take 3x and raise it to a new power. So that's 1 higher, and divide by that new power plus c, which cleans up to be simply x cubed plus c. And we know that the values, if you use -1 for x, should result in +1 for y plus c, which means we should be able to figure out what c is. -1⁻³ is still -1, so c must be 2. So the official solution to this problem is x to the 3rd plus 2, and that is the particular graph, and we now know the value of the particular plus c. You need to have both an x value and a y value in order to find that plus c value. All right, I hope that is enough of an introduction for you, and that you're able to have some success with the antiderivative problems that I've picked out from a couple different places in the book, and I will see you on Monday.